This video is the first of the computation review videos, and I'm just going to take these a page at a time. I will be reading from the book. You won't always see the screen, and then I have a sheet of paper that I can use to make notes on. So I recommend that you have some paper, and I'll walk you through the notes that I believe you need to know to be successful on the test. Starting on page 132, we are looking at fractions and mixed numbers. And the first thing I want to do on my sheet of paper is to make that header. So I'm going to write that same header, fractions and mixed numbers. And instead of flipping back and forth, I have my book open here beside me, and I'm just going to read from the book. And then I will make notes as we go through here. A proper fraction, and that word is in bold, so that tells me I need to know what that means. A proper fraction, such as 1/2, is a fraction in which the numerator, or the top number, is less than the denominator, the bottom number. So a proper fraction, and they give me an example, I'm just going to use theirs. The numerator that's the top, is smaller than the denominator, and that's the bottom. And more importantly, and they may go on, they do, a proper fraction represents a number less than 1. So let's put that in there, and then we'll take a look at what all this means. A number less than 1. So for example, the 1/2. Let's just go ahead and write that as our example. So the numerator is the top number. It is smaller in this case than the denominator, and so that makes a fraction less than 1. For example, let me draw a circle, and you can do the same. And I'm going to cut it in half. I do not want it to be shaded. So let me try a different approach here. I don't want it to shade. And for some reason, it's going to insist on doing that anyway. So I'm going to cut this in half with just a line. Now you could cut it that direction. You could cut it across or diagonally. It doesn't matter. But you are taking the one whole. This is a new feature of this iPad, and I love it for the most part, but not in this case. I don't want it to shade, but it did, so let me get a darker color, and I will go ahead and shade a little bit more. Let's just use this one. So if I shade one of those two pieces, that would be a half of this circle. So I would say that 1/2 is that lime green, the bright green. 1/2 is less than 1 whole. That is a proper fraction. Your denominator comes from 2 equal parts. So that is where this 2 is coming from. And the 1 is coming from the part that I've shaded as lime green. Okay, and that is a proper fraction. So if we keep reading, and I didn't realize, bear with me just a little bit, that I had room there. I didn't realize half my screen was cut off. Let me fix my, well, I guess that's okay. The example I will move over just a little bit as well. I think I'm going to need a lot of space on this page, so I'm just trying to conserve room. Okay. Back to the book, it says the top number, the numerator, tells the number of parts you are describing. So in this case, we're describing lime green. The bottom number, denominator, tells the number of equal parts into which the whole is divided. And in this case, it is 2. The whole may be a single object, like I have here, or a group of objects. So let me show you what they mean by a group of objects. Let's draw 6 circles. Well, there's one, and I'm just going to copy that. You can pause the video if you need to, or you can just follow along. Yours do not need to be perfect. They do need to be the same size, so it may be beneficial to trace like a penny or a dime. You want your pieces to be the same uniform size. And I tell you what, let's just do 4 of them. That will do what I need it to do just fine. We could do 6, but 4 will work, and that's a little, actually I'm going to go ahead and do 6 because it's working okay for me. So in this case, we have circles that are not connected. This is a group of circles or an array of circles. But you can also talk about a fraction this way. So if you cut this picture into 2 equal parts and you color one of the parts, not just one circle, but literally half of the circles you have. Imagine these are cookies and you ate half of them. You actually ate 3 out of 6, or you could say that you ate 1/2 of them. So you could use the fraction 3 out of 6, or you could talk about the picture itself would be a half. And we'll get into how those two things are equal a little bit later on. But those are still proper fractions because that top number is smaller than the bottom number. So it says the whole may be a single object. That's what we see right there. Or a group of objects. Same rules apply. And they give me some examples here. Let me come back to this book page and let's look right here. Example 1. How much of the circle is shaded? 2/3. 2 parts out of the 3 total parts are shaded. And we read 2/3 as 2/3. You could also talk about the part that is not shaded, and that would be 1/3 of the circle. Example 2, what fraction of the group of circles is shaded? 3 out of 4 circles are shaded, so we would call this 3/4. If you wanted to know what is not shaded, you would have only 1/4. Those are proper fractions. An improper fraction is a fraction in which the numerator, the top number, is equal to or greater than the bottom number, the denominator. An improper fraction is either equal to or greater than 1. And for this one, I'm going to draw these into my notes. So examples 3 and 4, I'm going to put in my notes. So let's come back to this page. I think I will change colors just so you can easily distinguish. Improper fraction. Is a fraction whose numerator, that's the top, is equal to or greater than the denominator. And that's the bottom number. An improper fraction is very different than a proper fraction. So let's look at an example. I'm going to use the example they use. I'm going to draw a circle. And I'm going to make the Y shape in this circle. It's upside down, but let's do it. 1, 2, 3. And that's not quite. Those should, in theory, be 3 equally sized pieces. So if this is a pizza, and we have 3 pieces in this pizza, maybe it's a personal size pizza, or it could be a very large pizza that's cut into 3 pieces. Doesn't matter. If you make this circle larger, it still has 3 equal pieces. If you make it smaller, it still has 3 equal pieces. The whole is cut into 3 equal parts. So that tells me my denominator. There are 3 equal parts. Okay, so let me pick up a different color. I think I'll use blue this time. And let's begin to color in the pieces of this pizza. So here's 1/3. 1 out of 3 parts I have colored blue. That would be a proper fraction. Here is 2/3. 2/3 are blue. 2 of the 3 parts are shaded. Still a proper fraction. But at the point that I shade 3/3, it's no longer proper anymore. It's called an improper fraction. 3 equal parts, 3 are shaded, so I would say that the whole thing is shaded. There is no unshaded part. And that also means that 3/3, let me move this down just a little bit. 3/3 is equal to 1 whole piece. So 3/3 is an improper fraction. All right? Improper. As opposed to that proper fraction where the numerator is smaller than the denominator. So let's consider example 4. And to do that, I'm going to need, not that. Let me do another drawing. I meant to copy that and save it, but I didn't, so I'll draw another one. Let's draw a circle, and let's cut it into 3 equal parts. It is important that the parts are equal, because then you can work with fractions. So pretend that mine are equal. I can already tell you they're not. So it's hard for me to draw on this thing and get it exactly right. Pretend that that's an equal division. And then I'm going to make a copy of that so that we have two of those identical circles. The example in the book shows that the first circle is completely shaded, just like we did a minute ago. And we said that this was 3/3. The circle has 3 parts. All of them are blue. So this is 3/3 shaded. And then they moved into the second circle and did 2 of them. Okay, so there's another third. That's 4/3 in total. And then here is 5/3 in total, because we have 3/3 in the first one and then we have 2/3 in the second one. So this is a total of 5/3 shaded. And that is definitely an improper fraction because that numerator is much bigger than the denominator. So both of those are examples of improper fractions. And let's look back at our examples here because they do give us some good information. Let's look at this one, example 3. This improper fraction stands for 3 parts out of 3 total parts. In other words, the value of this fraction is 1. It's the whole thing. Example 4, 5/3. One whole is divided into 3 pieces. The numerator 5 refers to 5 pieces. This improper fraction represents 1 whole plus 2 more pieces. And then we need to talk about a mixed number. And if you notice, the mixed number looks exactly like example 4. So let's first of all define what a mixed number is. So let me get a different color and I'll give you a short, sweet definition of a mixed number. A mixed number, as its name implies, has both a whole number and a fraction, and I'm going to use my own term here, stuck together. That is not a proper math term, but it'll get the job done. So let's look at this one. I'm just going to bring down this picture and let's talk about it. Would you agree with me that we have one whole circle that is shaded blue? One whole circle is blue. And on this circle, we have 2 out of the 3 parts being blue. 1 out of 3 is not shaded with blue. So the mixed number would be this one whole circle and this 2/3 of that circle. Okay, and to get the mixed number, we need to squeeze these together. So we would have 1 and 2/3. That is called a mixed number. So then we could say that 5/3 and 1 2/3 are exactly the same amount. There are just two different ways of writing them. Okay. You can always, every mixed number has an improper fraction, and every improper fraction has a mixed number. And on the next page, we will look at the mathematical way to do this. But for right now, I just want to show you one more picture. And I want you to draw this with me. I'm just making this up. It is not in the book. This time, let's use a square. So let's draw, actually, let me get a pen instead of a, so let's draw a square. 1 2 3 4 5 6. I'm using grid paper, but you can just sketch yourself a square. Doesn't have to be perfect. Okay. And then let's cut this square into 4 equal parts. So I will say cut it in half that way, cut it in half that way, and you will have 4 equal parts. And before I mess it up, let me just take a picture of it, because we're going to need another one just like it. Actually, I think I want to do yet another one just like it. So I want you to draw this model. You do not have to color yours gray. Just draw me some squares like this. My computer is automatically making them gray. I need to go back and figure that out. So I have 3 identical squares, and each square has how many equal parts? Each square has 4 equal parts. That will be your denominator. So any fraction we write must have a 4 on the bottom. Up here, we had a 3 on the bottom because there were 3 equal parts. But for these, our denominator would have to be a 4. And only a 4. And you might be thinking, well, if I count those, I have 12. 6, 7, 8, 9, 10, 11, 12. And that is true. But in one square, one single square, how many equal parts do you have? And that would be 4. So that is your denominator. Okay, let's shade, and you can use a highlighter if you have one, or you can just color with your pencil. It doesn't have to be fancy. We're just getting the concept. I'm going to shade one whole square with yellow. So I'm coloring one whole, or I could call that 4/4. Right? If I'm shading all 4 of the parts, that's 4 out of 4 that gets shaded, so that is 4/4. So we have shaded 4/4. Remember, that denominator has to be a 4. We don't have any control over that. We can decide how many parts to color, and that gives us our numerator. But the denominator is determined by the number of parts in a square. And then I want you to jump all the way over to the end one and do the same thing. I want you to color 4 parts and then write me a fraction for the part you colored. So I'm using yellow, so I would say how many of those parts are yellow? 4/4 of them are yellow. So this is the number of yellow. This is the total parts that I cannot control. Okay. So we could say that we have colored 8/4 or 8 parts, or we could say that we have colored 2 whole squares, because here's one hole and there's another hole. So we have 2 whole squares that we have shaded yellow. Now let's put one part, and you can pick the part you want to color. I'm just going to put it in this one, but it doesn't matter which of the parts you color. All right, I'm just going to do one. So 1/4, that would be, the 1 is the yellow part. The 4 is the denominator that I cannot control. So 1/4 of that square is yellow. So 1/4 is the fraction. So the mixed number for this picture would be 2 and 1/4. That's the mixed number that describes this picture. This is called the mixed number. Okay? And I'm going to leave it right there. We'll talk about the improper fraction that goes with it on the next page. But for right now, let's just leave it here. If you understand what I've done here, you have the gist of this and you'll be fine on the next page. If you do not understand what I've done here, I would recommend stopping this video, bringing this page to your instructor, and asking him or her to go over it with you a little bit more. We have one more thing to do, and that's to look back at this box on page 132. An improper fraction can always be written as a mixed number, and a mixed number can always be written as an improper fraction. I used to think of these as being twins. They don't look the same, but they are the same. Identical twins have the same DNA. They're exactly the same person in one sense, but they don't necessarily look exactly the same. Most parents, even though twins are identical, they can tell them apart by some feature. So some examples here. Let me take 5/3. That's the improper fraction. That is the same as 3/3 plus 2/3. And we can see that in this picture right here. We've got 3/3 in this one and 2/3 in that one. And that's the same as 1 whole and 2/3 of another one. We can see by looking at that picture that 5/3 and 1 and 2/3 are the same amount. You could also start with the 2/3. So you could say 2. Let me draw this one for you. Let's see if we can represent this with math, because this could get a little confusing quickly if we don't make sure. So I'm going to draw a circle. And I don't know what that is. There's a big old white box in my circle. Okay, so let's cut this circle into thirds. So I'm coming this way, here, again, pretend that my drawing is equal. Let's take a copy of this so that I don't have to keep drawing this. And I'm actually going to need 3 of these, and here's how I know that. I need 2 of them to be whole. In other words, I need 1 whole and 1 whole. That's going to give me the 2. So I'll use yellow again. Here's 1 whole, and here is the second whole number. Now I could also say, yes, that's 1 whole, but it's also 3/3. And this is also 3/3. That's the 6/3 that they're getting right here. And then in this last circle, I want to just shade 2/3. There is no whole number because we don't have enough to make a whole if we only have shaded 2/3. So maybe these are lemon pies. And the first lemon pie is completely intact. Nobody has touched it. Nobody has touched the second one. The third one piece is gone, so there's only 2/3 left. So we can say a couple of different ways here. Let me draw a line so that breaks up your eye just a little bit. On the top, we could say that that equals 1 plus 1 plus 2/3. That's 2 whole numbers and 2/3. Here, we could say that we have 3/3 plus 3/3. That's 6/3. Plus 2 more is 8/3. This is the mixed number. This is the improper fraction. But have we changed the amount of pie? We haven't. We have 2 whole lemon pies and 2/3 of another one. And you can express that as mixed numbers or improper fractions, but it is the same amount of pie. So you might be thinking, why do I need both of them? If they both mean the same thing, why do I have to learn them both? And that is because mixed numbers are used when you add and subtract, and when you multiply and divide, you will need the improper form. On the next page, we will learn how to convert back and forth between these without having to draw a picture. I'll show you the mathematical algorithm or rule that you need so that you don't have to see a picture.